Hi, my name is Anna Ivanova. Today I'm going to tell you about a project we did with Matthias Hofer called Linguistic Overhypothesis in Category Learning, explaining the label advantage effect. Imagine that you're an astronaut sent on a mission to a foreign planet. Upon arrival, you discover that the planet is inhabited by aliens. Some of the aliens are friendly and should be approached, while others are hostile and should be avoided. Your goal is to learn to distinguish between them. This is the setup for an experiment conducted by two different research groups in order to establish the relationship between words and category learning. What did this experiment show? The original study was conducted in 2007 by Lupyan et al., and they used the evidence they collected to claim that words boost category learning. In 2011, Brojde et al. Replicated these findings, but also extended them to show that words can either boost or hinder category learning. Today, I'm going to present you a computational model we built to account for both sets of these results. Specifically, we will aim to show that words provide learners with overhypotheses or prior expectations about category structure. Over the course of this talk, I will start with some background about the label advantage effect. I will then describe the experiments by Lupyan et al. And Brojde et al. In more detail. I will describe our model and the predictions it makes with respect to the alien experiments. And I will conclude with some implications for the questions of language and thought more broadly. Over the last few decades, multiple studies have shown that category learning happens faster in the presence of verbal labels. Here, by category learning, I refer to the process of classifying objects into distinct categories based on one or more features. The label advantage effect states that this process happens slower in the absence of labels than if the objects are accompanied by the verbal labels, in this case, spoon and fork. Why does the label advantage effect exist? I'm going to describe two models that have tried to answer this account. The first one is the labels as features account, according to which each object is characterized by its perceptual dimensions, such as shape and material, and additionally by the label that got associated with this object. So label in this case serves as additional information that helps to classify objects in concept space. The second account, labels as cues, argues that labels are more than just another feature, that in addition to being used as extra information for categorization, they also provide a top-down influence on the conceptual space, highlighting the perceptual features that are likely to distinguish between the categories. In order to test the labels as cues account, Lupyan et al. Conducted their alien experiment. In the alien experiment, they presented participants with two kinds of aliens, approach and avoid. The differences between the categories were based on slight differences in shape. The participants saw aliens one at a time, had to decide whether to approach or to avoid it, and received feedback on their decision. In addition, half of the participants received a label together with the feedback, Liebisch or gracious. What the experiment found is that participants in the label condition learn the categories faster than participants in the no label condition. Here you see the learning dynamic over time, and we can also aggregate over blocks in order to show the overall label advantage effect. Importantly, labels here did not provide any new information. Participants accessed them after they had made this decision, and participants in both groups were receiving feedback about whether or not they answered correctly. In addition, this effect generalized across written and spoken labels, but did not generalize to nonverbal cues, suggesting that indeed there is something special about words that make it easier to learn the alien categories. So in sum, the evidence provided by Lupyan et al. Was unaccounted for by the labels as features model, but was predicted by the labels as cues model. 4 years later, Brojde et al. Replicated the original study, but they went further. They asked whether the results were influenced by shape bias, the tendency that people have to assume that word meanings refer to categories that differ according to shape. To test this hypothesis, they also looked at the label effect on non-shape-based categories, specifically categories based on texture and categories based on brightness. What they found is that for shape-based categories, participants indeed learned better in the label condition. But for non-shape categories, this effect was reversed. The presence of the labels hindered learning instead of facilitating it. Brojde concluded that words direct attention to some stimulus dimensions over others. What's interesting about these results is that they are not accounted for by either labels as features account or the labels as keys account. Neither of those can explain the hindering effect of labels on category learning. And here's where we come in. Our model, linguistic overhypothesis, was built to explain both the facilitative account of labels and the hindering account of labels under different category structures. So what do we mean when we say linguistic overhypothesis? Imagine a learning scenario similar to the alien experiment. In this case, the participant sees an object and needs to classify it as useful or useless. In this first trial, the participant doesn't have any information to make the decision, and so she randomly chooses to say useful, and she happens to be correct. Then she sees the next object that has the same shape as the previous one, but is made from a different material. And so the learner needs to decide whether to categorize based on shape or material. The learner might have some kind of expectation in her mind about which feature, shape, or material is likely to be diagnostic of the category. In this particular case, the learner is ambivalent. It is a 50-50% chance. And so the learner, let's say, decides to go with material, says that this object is useless, and she happens to be wrong. So the interesting part of this whole process is these overhypotheses, the expectation about which feature is going to be diagnostic of category membership. It doesn't tell the learner about the category structure itself. It just tells the learner which feature to be paying attention to, which feature is likely to be important. So how does this relate to the label advantage? Well, imagine the same learning scenario. The learner sees the object randomly, says useful, happens to be correct. But now, in addition to the feedback, she also receives a label, Liebisch. And receiving this label reframes the learning problem somewhat. Now, when she sees the second object, she not only needs to decide whether or not it's useful or useless, she also needs to decide whether or not it's Liebisch. And so now, the presence of this label might trigger a different expectation in the learner's mind. The learner might say, well, most words I know categorize objects based on shape. And so she's going to be more likely to prioritize shape over material as a basis for classification. So in this case, she will choose to group this object with the object before, see that this one is also useful, and she will be right. As you can see, the learning process in the no-label condition and the label condition is exactly the same. The main thing that differs is the overhypothesis. In other words, the presence of a verbal label has altered the learner's expectations about likely category structure. The learner was more likely to use shape as a basis for classification. How can we formalize this idea in a model? Well, we are going to represent each object as a point in multidimensional space. Here we're looking at two axes, shape and material. As you can see in this example, the shapes of the two categories are different. Mean shape A is far from the mean shape B. And the material for categories A and B is not very different. The means are almost identical. And so After a learner sees a bunch of these categories out in the world, she might start constructing a prior over all categories of this type. So in this case, for shape, she's going to start assuming that the mean shape in categories A and B are likely to be different. In formal terms, she's going to have a high bias for the shape dimension. For material, though, she's going to start assuming that the mean material A and B are likely similar. In other words, she's going to have a low bias for material as the diagnostic dimension. So this is useful because it will help the learner categorize objects for novel categories in the future. But obviously not all categories are shape-based, so this prior is not always going to be able to capture the relevant distinctions. What we want is to be able to flexibly manipulate this prior based on the context, such as the label presence. And so this is where the overhypothesis comes in. It's a prior over the shape bias and the material bias dimensions. All right, so now we have all the pieces in place. What does the learning process actually look like? The learner starts with the overhypothesis, and the overhypothesis helps the learner generate the shape bias and the material bias values. And the shape bias will then lead to the learner sampling the mean shape for categories A and B. If the shape bias is high, the mean shapes are likely to be different. If the shape bias is low, the mean shapes are likely going to be similar. And the same thing is going to happen with material. So now we have a category structure set up, and the learner might generate some exemplars and compare them with the actual distribution that she observes in the data. And based on this comparison, she will adjust her expectations accordingly. So what's interesting about this model is that it's exactly the same for the label and the no label conditions. The main thing that differs is the overhypothesis. So in the no label condition, we don't assume any particular difference between the shape bias and the material bias. So the learner will be paying some attention to both. In contrast, in the label condition, the learner will assume that the shape bias is much higher than the material bias. So she will still be able to learn material-based categories. It will just take more time to do so because she will be paying more attention to shape. All right, so what does this model predict in the context of the alien experiments? Here are the results from Lupyan et al. The label condition has higher accuracy values than the no-label condition, and this exact pattern is replicated by our model. One other thing we can do, though, is if you remember, the categories in the Lupyan experiments were all shape-based, but we can also look at how our model would do for material-based categories. And what we see is that in this case, the presence of a label hinders learning, and the participants are slower to learn relevant category distinctions over time. And this is exactly the interaction that Brojde et al. Tested in their experiment. We saw that labels helped learn shape-based categories, but hindered learning non-shape-based categories. And this is exactly the pattern that our model captures. So this is pretty cool. We have a model that provides quantitative predictions about the effect of a verbal label on category learning, and it can predict both the facilitative and the hindering effect of the label, depending on the structure of the category that needs to be learned. So what does this model imply for the broader question of language and thought? Well, first we show that category learning proceeds via the same mechanism, whether or not the learning takes place with labels or without labels. All that differed was the specific overhypothesis that was used. Second, we show that learners have different priors about general categories out in the world and categories that denote word meanings. And finally, we show that computational models can provide precise quantitative descriptions of the language-thought relationship, thus paving the way to mapping out the interface between language and thought more broadly. With that, I would like to thank you for your attention.